still, you're going to talk about automatic line balancing. How is that possible? You are working with Lamborghini, BMW class and other companies, so you are the go-to cycling and sequencing tool. So let's cut this short and now enjoy. Well, when I was planning my presentation, I thought about many things that I could talk about regarding automatic line balancing, but it's much more interesting to tell you a story here. So I think all of us together, we should think about how exciting synchronization actually is. When we look at a C-Class Mercedes or BMW or Volkswagen, in a typical assembly line, there are thousands of people coming in every morning, and those workers work on thousands of different vehicles. When we talk about different ones, it's not just different types of engines and roofs and so on, but in the end, it's also about manufacturing the same basics on the same line. So we have mixed lines nowadays, and there are SUVs, limousines, and so on, all kinds of cars at the same line, up to 12 types on the same line. Now, to make sure that this works, we have 10, 20, 60,000 workflows that were analyzed with different systems, and all of those the steps of the tasks have to be carried out. And the question is, who of those employees does which of the 60,000 tasks on the line? And now this synchronization should be as efficient as possible, and at the same time we want to have smooth production. It's like a choreography. So we want to have finished vehicles every minute. And when I see this in practice, I'm always astonished that it actually works. And what's even more fascinating is that there is a group of planners, a team of people who have an overview of all this. They have an overview of all the different types and versions. They are the ones who make this choreography possible so that the synchronization works. And that brings me to what I was going to talk about. That's the origin of TAKTIQ and AssemblySuite and the automatic line balancing. It all started when I was writing my PhD. I was very enthusiastic when I looked at this process for the first time, and I found out that this process does not run as smoothly as it looks. There is a very high level of complexity. The planners have to work very hard to plan all this, and it's very hard to plan with all the bottlenecks and it's very difficult to include efficiency and so on. And when you think about the possibilities to combine, it's very difficult. We have 20 tasks at 5 workplaces, and that gives us 24,225 possible combinations. So when we extrapolate this with larger numbers get so big they don't even fit on the slide anymore. That number of possibilities in mind, I looked at what the planners do. And of course, they use computers. They already did that back in the days, but they don't really use those computers. They rather had a sort of software that worked like a digital notepad. So they entered information there, but the software didn't actually help them to come up with better solutions. Now, with all the pressure that they had with new bombs, new versions, and to always come up with the perfect solution, it was becoming more and more difficult. And the planning team was aware that if they made mistakes in their plans, this will end up at the worker at the line, so there will be a line stop and so on. So I realized that it was an exciting topic. The planning teams are just as excited as I am, but the level of complexity and the level of pressure was like a veil over their work. And I had studied economics and computers, And I knew that computers had a lot of power. And if they cannot come up with a perfect solution, they should at least be able to provide alternatives and make suggestions. And it was clear to me that the potential was not leveraged in practice, because this would make the planner's life easier, and it would have great impact in production. And I remember I spoke to my professor about this, and I told him about those problems, and I said, it's such an exciting topic. And then he turned around, he opened a closet, and he pulled out 3 books, and he threw them on the table, and he said, Mr. Altemeier, automatic line balancing, it has been solved for 40 years. I can give you so much more documentation. It's all done. So I left the office. I was totally upset, and I started doing my research. And the answer is yes. Well, in theory, in university, in science, the problems have been solved for more than 40 years. So I was wondering, why is this not being used? Why do the big OEMs not apply all this? And then over the years, I learned about all the challenges involved here. But I wasn't scared away. And after talking to a planning team in great detail, I came up with the first prototype. This is a software that does an automatic allocation with individual workers so that it reduced bottlenecks. I fed tasks into the systems and workplaces, and of course the processes. Now the tasks and the workplaces were imported quite quickly from existing topics. But what about the process data? I called Peter, who planned the line I was looking at, and I said, Peter, I need the process data. And I remember Peter starting to laugh. He said, well, we don't have documented process data. But to be honest, what we came up with was I had to go there and look at the line in person. That's what I did. So in the early shift, with lots of coffee, I went to the line, and the planner was already there early in the morning, and he handed me over to the foreman, and he said, okay, this is the guy who's supposed to learn what it actually means to build a car. And the foreman found out quite quickly that I was not too clumsy. You know, I did some work on my bike and so on, so I knew what I was doing with the screwdrivers. And then he took me to a workstation that that was quite hectic. He wanted to show me how individual control units had to be built in the engine components. You know, many things were happening at the same workstation. So there were vehicles that had only 27 seconds, and others had 270 seconds. So cycle time 100 seconds. There was a lot of stress, a lot of drift. And on the 3rd or 2nd day, the foreman asked me to come in. There was a picture hanging on the wall of me, and it said, okay, well, this, and then he said, okay, well, this cable has to go there. And they were not amused. They had to reopen the vehicle and to make up for my mistakes. So I really gained a lot of respect for assembly lines, and that also includes the workers. There is so much complexity, and this really motivated me for my project, but I also found out that it won't be too easy. Then over 3 years, I started with many prototypes, new KPI systems, quicker automation of processes. That's also something we looked at even then. But I also learned that in-house prototypes are hard to professionalize. And I felt that it would be better to create a software outside of a company than inside of it. That's why I founded TAKTIQ. And over the first 3 years, we invested a lot in the first software version, in the first TAKTIQ AssemblySuite. And then in 2012, we won over a first OEM, and we carried out a workshop to test our software together with them. So we were so motivated, and we started the workshop, and the planners provided all the information, and I'm sorry to say, but it was an Excel spreadsheet. I'm very grateful for the colleagues that they did all that work. So we had high expectations. We pushed the infamous green button, and the system calculated a solution. So during the workshop, as is always the case when we have innovation cycles, they were quite amazed. Within seconds, we had a new allocation solution. We looked at it, and then we walked through this workflow by workflow. And well, it didn't take long until we learned that, I think it was one of the planners, I think about 5 or 6 processes in, he said, this is bullshit. Well, to get the material for one process is one thing, and then the assembly is another thing, and then we have 2 different colleagues. And I said, okay, well, this, of course, it won't work in practice. The workshop was over much sooner than we had hoped. Now, in software development, there is one advantage. Some colleagues love to work at night. They start in the afternoon. It's not like they work round the clock, but they like to work at night. So overnight, they had a lot of coffee, and they added a function to the software that's grouping of processes, so that these processes are always combined when we shift something. In the next morning, in the workshop, we presented this new function, and we could actually test it out. So again, we were motivated to include the individual groups and do the second test. We pushed the button again, and it looked amazing. So yes, and we were able to walk through this for a little longer than on the first day. But eventually, another planner said, okay, well, in this solution, the worker has to walk all the way around the car and is also standing on the other guy's feet, and the height of the vehicle is not correct either. Okay, so this workshop was actually over at that time. But despite this early ending, the presentation was impressive enough, so we were allowed to come back many times. Now, we started to play ping pong over years. We had this ambitious presentation of automatic line balancing and the reality of the planner. So we did many workshops with many OEMs over time, and we always tried new things out. And I would like to share some of those ping pong points with you, because they are crucial for automatic line balancing. Let me give you an example. This is our major interface. I don't have time for all the details, but if you're interested, please visit my booth and I'll be happy to show it to you. So we had those suboptimal walkways and the fact that they had to run around the vehicle. So we included the example of working positions. So we knew exactly where which process took place, and we also have a height. So the system knows at what heights people can work, so it always matches. And the results make sense. So the average consideration is not enough of an average load. So that's why I said that we considered different KPIs, different cycle times. It goes all the way down to a dynamic simulation of the load for every individual job at every workplace and every drift. And now, obviously, I'm saying obviously today, but the system just shifted things around. And people said, okay, well, that kind of shifting, it doesn't make sense. We can't tear down the entire whole and change everything. So we came up with different methods. On the one hand, we adapted the algorithms in such a way that they favor solutions, simple solutions, and the planner doesn't only get one solution. That's not just pushing a button and they get one solution, but they get several solutions. And in those solutions, they can see what effort is required in order to achieve which level of efficiency. So it depends on the organization, really. What are we looking at on the line? Is this something where we can change more things around or not? And then the planner can say, can make wishes and say which workplace they want to optimize. If they have a stable process, they can say, okay, this process cannot change, but another one can, and then they can look at the entire line and see where they can have drifts, special equipments, and where this is not required. So we had some feasible solutions, and we visited an OEM that we used for calculating this, and they said, well, our Works Council won't accept any solutions if ergonomics are not right. So they said if one ergonomic street light switches from yellow to red, the solution is dead. So we included a full assessment of ergonomics according to EAWS, and it has already been certified, as we announced last year at the summit. So whenever we change some balancing, when we change anything, ergonomic evaluation is renewed. And this is also done in automatic line balancing. If you don't only want to improve efficiency, but also want to achieve ergonomic targets. Now, a problem was that certain fixed points and cell phones were not considered. Tools are required for individual processes. So we came up with a concept for tools and features, and it allows us to map certain features. Here, for example, the process knows that they need a window, they know the sizes of the wrenches they have to use, and the system knows what goes together. It's, the question of the effort is always asked about maintaining this automatic line balancing. And there are two things here. On the one hand, we have a maximum support for maintenance because we learned again and again how long it takes. And we can now do 150 processes in one day if we start at 0. And the things that we maintain here are not only used for automatic line balancing, but there are other uses. For the example, for the planner who works on the system manually. So the planner knows why a process is here. So if somebody is doing something, the next person can see why the process can only be in this place. So this information is not only uploaded for automatic line balancing. And one last point. The separation of automatic and manual line balancing, we turned away from that black box mindset because it doesn't make sense. Automatic line balancing has to be integrated in the manual process. So today's customers don't ask the question of whether or not they should do automatic line balancing, but they think about to what extent they can use the support functions and at what level they are. It's like autonomous driving. Nobody is driving fully autonomously, but it's nice to have a distancer and other assist systems. And it's the same with the system. We can decide and decide how much we want to do and how much we want the system to do. The integrations are provide different scenarios, and we can simulate with different programs. Now, why am I telling you all this? It is exactly this ping pong between the practical implementation and further development of the software between TAKTIQ and our customers over a period of time of 10 years. That is what was made possible by our software. And all the mindsets and questions and problems that are, all of them have a right to exist. That's everything that comes to mind when the planners hear automatic line balancing. We've heard it all, and we are very grateful for the patience that we have been granted over the years. To sum it up, we believe that there are three crucial things for automatic line balancing and for making it work. On the one hand, the real world has to be described sufficiently. So not the entire world, but everything that has to be borne in mind. All the relevant target variables have to be considered. Ergonomics, the effort for changes, and so on. All of this has to be considered. And the major point, the automatic line balancing and the proposals have to be integrated in the normal planning process. And that also means that we have to take people along, because the question is, do the planners actually want this? Do they want the system to do this automatically? And once this is all implemented, both sides can win. On the one hand, there is the planner, because they have a higher degree of transparency, a greater understanding of the line, and greater expertise. They are faster in changes and short-term changes on the line, and they get support with the suggestions that they get. Oftentimes they wouldn't have come up with this themselves. And production benefits, because it reaches its efficiency targets, and it has smoother and more even ergonomic production. So let's hope that nobody ever forgets a cable again, just like I did back then. Now, people often ask what this actually brings in practice. Well, it depends on where you're coming from. If you have 75% line balancing, you can bring it up to 85, 95%. But it was exciting when a planner of a big OEM called us, and he said, well, this automatic line balancing, you have a line that where I did many manual processes. I'm at 91%. So please show me that you can do more. And we did a 2-week workshop, and we had the group leaders from the line in that workshop, and we enabled the system. We made it to 96%, but there was a lot of changing involved, so we decided not to do it, and we ended up with 94% in the end. Of course, we at TAKTIQ were very proud of such results, because it's always nice to see the planners who are astonished and surprised of the possibilities. But it doesn't mean that we're done. We're everything but done. This ping-pong process is that we're still experiencing. We call it an exchange of experiences nowadays, because just like serious production continues to change and has ever new challenges, we also develop our assembly suite further, so that it remains the one and only line balancing tool. And that's all from me. I'll be happy to answer any questions.